Hello, so in today's video, we're going to look at how we would describe a combination of transformations when we apply a combination of transformations onto a function. So in the previous video, we've looked at stretches, reflections, translations of functions, and how we could use the function notation to describe that. So in this video, we're going to look at a combination of transformations. So let's say we've got some four real numbers here, A, B, C, D. So how could we describe the transformation that maps the graph y equals f of x onto a graph y equals a times f of bx plus c plus d? How could we describe the transformation that maps perhaps a graph like this? Let's just call this here f of x. And how could we describe the transformation mapping it onto this new kind of new graph, whatever that may be, something like that maybe? How would we describe this in words? So there's a key rule that we always need to follow. So the key thing is that we're using a combination of transformations. We're stretching there by a, parallel to the y-axis. This is, if you remember from the previous videos, this is a stretch parallel to the y-axis by a factor of a. This is a stretch parallel to the x-axis by a factor of 1 over b. So this time 1 over that number. This is a translation in the x direction by minus c, so a vector minus c, 0. And this is a translation by a vector of d in the y direction, so a vector 0, d. But the order is going to matter. So the order really does matter in which we do these transformations, because otherwise we get a different, when we actually solve like the expression for this function here, we would get a different result if we do the transformations in a different order. So the order really does matter. Let me just make a point of this here, that the order really matters. So order matters. Now, how do we describe the transformation then? So the key thing is that we're going to do the C first. So we're going to do this translation here first. So the first step to go from this graph to this brand new graph is that we do the translation first. So it's a translation, and as we saw in the previous videos, when we add C inside the function that we're inside the input that we're inputting into the function, this is a translation by a vector of minus c, 0. So actually the negative of c. We always do that first. And then we once we translate it, we're then going to stretch this this x coordinate there, and we're going to stretch it parallel to the x-axis. Remember, this b is a stretch parallel to the x-axis, so parallel to x-axis by a scale factor. I'll just call it SF for scale factor of 1 over b. Then your next step is, you've done the C there, you've done the B there. The next step is to look at the A, and this is a stretch again, but now we're stretching the y coordinates. So we're stretching parallel to y axis, and this is by a scale factor of just a. So we're just stretching, multiplying everything by a, so the y coordinates are going up by a factor of a. And then the last step is to do the d. So this is again is a translation in the y direction. So a translation by a vector of 0d. So if d was positive, it would go upwards. If d was negative, it would shift downwards, basically. So shift up or down. So that's the order. And we always do this order: C, B, A, then D. That's how we do the transformation. Now, what about reflection? So let's say you've got a graph. You've got y equals f of x up here, and then you're going to transform that graph into y equals minus 2f of x. So, okay, are we going to do this stretch first, this stretch by scale factor of 2 first, or are we going to reflect the graph upside down because of the negative sign there first? So what order do we do things when we've got a stretch and a reflection like this? So the key thing to remember is it doesn't matter. So it doesn't matter. So stretches and reflections, it doesn't matter which order you do the y. So again, the key thing here, this is a y reflection and this is a y stretch. So it doesn't matter in this case whether we do the y stretch first and then the y reflection, or whether we do the y reflection first and then the y stretch. So it doesn't matter in this case. So we could either stretch it parallel to the y-axis and then reflect it over the x-axis, so upside down, or we could reflect it upside down and stretch it by a scale factor 2. Doesn't doesn't matter. Now, how about this one? So how about if we think about the x coordinates, instead of stretching the y coordinates, this time we're stretching the x coordinates and we're reflecting the x coordinates. So we're reflecting over the y axis this time because of the negative sign there. So again, are we going to do the reflection first, this reflect the x coordinates and then stretch the x coordinates? Or are we going to stretch the x coordinates by 1/10 first and then reflect it over the y-axis and reflect the x coordinates? Again, doesn't matter. It doesn't matter whether we do the x stretch first and then the x reflection, or the x reflection first and then the x stretch next. So again, doesn't matter in this case. But the key summary that you need to know is, regardless whether this A there is positive or negative, regardless of whether that B there is positive or negative, so these A and B stretches, you always follow this order for your transformation. So to go from a graph y equals f of x onto a brand new graph y equals a times f of bx plus c plus a d, the first step, the first transformation, is you translate by the c first. So you translate by a vector of minus c, but shifting it backwards by c in the x direction. Your next step to your transformation is going to stretch it parallel to the x-axis by a scale factor of 1/b, so 1 over that number there. Your next step, once you've done that transformation, is you're going to stretch parallel to the y-axis by this scale factor of a, because you're multiplying all of your y coordinates by a now. And then your last step is you're going to translate it upwards by d, or downwards if d was negative. So you're going to translate by a vector of 0d. So that's always the order in which you do these transformations. And if you can just learn that's the order, then you'll be fine with describing transformations of functions and graphs of functions.